Hey, it's Philip Foyle here. Today I'm going to talk to you about microservices. This is a topic for software developers. What we're going to talk about is what a microservice is, some reasons you might want to choose microservices, some implementation choices you might make, and some problems that you will inevitably encounter. And then we're going to sum up. So what is a microservice? Well, I think first and foremost it's a buzzword, and you'll hear it a lot. And I think there's been a real sort of move away from this is a knee-jerk reaction, but there are still some reasons why you would want to choose it. The idea of a microservice is that it's a module and it has a boundary and can be deployed independently. And what does it mean by having a boundary is that it encapsulates a set of cohesive processes or data or both, and often that's around a particular business domain or a particular problem that the microservice solves. And typically, a microservice will communicate with other services asynchronously. And often that means that it will publish an API or a set of message payload specs, wire formats that you will need to use to communicate with the microservice. And typically, those payloads have a version so that you can enjoy a particular level of compatibility provided you're using the right version of the payload to communicate with the service. Some reasons why you might want to do this are that you have independent teams. They might have different priorities or work schedules, or are working on different areas of an application or a different application altogether. You might choose microservices if you have a variety of different operational requirements within your application. Like you might have parts that you expect to have to deal with a very high volume of requests. You might have other parts that don't get used very often or very frequently. You might have one part that only has to give a response within the next day, whereas you need to give a response within milliseconds from another part of your application. Or you might have parts of the source code that change really, really often that you want to isolate and take away from other parts of the software which don't change very often, so that you don't have to test all of those things every time that you want to make a small change to the regularly changing component. Some benefits include that microservices can have loose coupling to each other. What that can mean is that you don't have to test things as carefully, provided that you keep the message specs the same. And like in all of these cases, there's some nuance there, and like you can really easily mistake that you've got one of these benefits when actually you don't. Another benefit is independence, and one final benefit is that, and this is important if you have multiple teams, that the team can focus on just doing one part of your application right and not have to worry about all of the other interactions with it. And that relies on that boundary being very clear. Some implementation choices that you can make when you're implementing a microservice are the communication protocols that you will use. REST is a very common protocol now. It's very popular. there are a lot of other ones out there that you could choose. SOAP, XML over TCP. Protobufs is still pretty common. There are different choices that you can make for storage, and if you're genuinely independent in terms of your microservices, then you could make whatever choice you like about how you store the data that's inside the boundary of your microservice. You could choose your database provider, you could choose file storage, or you could choose a document store, or a log store, or any number of these choices, and you're able to make that choice and perhaps change it whenever you like, provided you maintain that abstraction around the microservice, so that nobody ever interacts with the data directly except via the boundary that you impose on that microservice. And I think that that's one of the things that can really go wrong, is that if you lose control of that data, then you lose control of your ability to abstract that area of your application. You can choose whichever implementation language or framework. Often within an organization, you'll find that things are homogeneous. I have worked in organizations that had different implementation languages. I've also worked in organizations that standardize those things. So, for example, I worked at one where there were multiple different teams. I think there were roughly 12 in the main site, and we were in a satellite site, and there were 3 teams in that on that site, and those teams were all using in-service bus to communicate with each other, and then we were using JSON to communicate between our systems. And you sort of have the choice about where you draw the boundary. And in our case, we opted for modules within a monolith, and there are a lot of people choosing that, but there are reasons why you would want to sort of have independence as well. Like with 3 teams, it's really easy to control, and the kind of application that I was working on at that point, it's really easy to control when you ship code. But if you've got 18 teams working on lots of different disparate pieces of application, then coordinating everybody and shipping at the same time is really hard. Okay, you can also choose how and where to host. Containers have become very, very popular, and there's good reasons for that. I think the main one is your ability to chop and change how you scale, how you build, where you host. Those decisions can be made independently of how you build your software now, and it makes things really easy. But there's still infrastructure as a service out there in use, and many applications still run on on-premises hardware. So those are choices that you could still make when developing a microservice. How and where to host. Most of the pitfalls, most of the cons that you incur by choosing microservices are due to the extra complexity that that you have to deal with as a result of things being in different modules. One problem is that it can be difficult to diagnose faults, and in particular, you might need to narrow down where the fault is actually occurring, especially if you have a single user interface that sits on the outside of several APIs. sometimes microservices can encapsulate the whole lot of that. Like we'll have a presentation layer that is inside of the microservice as well. But if not, you might find yourself on a bit of a fact-finding search when something's going wrong, and you might even find that a fault is partially attributed to somebody that's on another team making a code change and rolling it out, and might not even have very much control over whether when and where that gets fixed. They might be in a different time zone to you, for example. The layers, and when I say layers, I'm talking about the OSI stack. If you're in a single executable application, you never have to worry about your wire format because you are just crossing between different addresses in the application. You don't have to worry about latency. You don't have to worry about people intercepting and tampering with your requests and your responses. So you don't have to worry about security or authentication or encryption or any of that kind of stuff because it's all within the machine and you can trust everything there. You don't have to worry about accidentally breaking another application's behavior by inadvertently changing what they believe to be a constraint that they had on you. Versioning, especially if you really take modularity seriously, versioning is really important because you can't just add a field, you can't just rename a parameter, you can't just, yes, you can add a field to the response payload, provided the requester can deal with that gracefully. Yes, you can add an optional parameter to the request payload, provided you don't impose that on what might not have been an updated calling service. You might change the format of a field that you're sending out. That might not necessarily be part of the schema that you've published, but if you change the format of one of your messages or one of the properties in one of your messages, well, who knows who has been relying on that, and that's so that's where the complexity comes in with the versioning. Not every change is a schema change, and not all faults are constrained to accidental changes of the schema. Sometimes you can actually accidentally introduce faults by not even doing that. And I think so. The final really, really big problem with modules is if you have dependencies, then it really will chip away at your ability to do, some of these things that you, if you want to ship on a different schedule, and you want to have a different priority for something, that has an effect on the things that depend on you and the things that you depend on. If you want to deploy independently, well, you got to make sure that when you're deploying, you're not affecting the applications that require your uptime. That this is where microservices really hit the road. It means you have to think more carefully about how you build, modularize, host, secure your software, and that is because if you want the benefits of modularity, there are some costs associated with that. Okay, so summing up, there are some good reasons to choose microservices. And, if you want those good things, there are some trade-offs that you need to impose on yourself. And I'll say this one more time, there are some things that you can do where you achieve all of the complex outcomes of having microservices and then never achieve the benefits that you originally sought out by choosing that architecture. So be careful. I'd love to hear what you think. Love to answer any questions you have. Hit me up. I'm on email. Post a comment in the comments here, or hit me up on Twitter or Threads. Cool. Talk to you next time.